Okay, let's graph y equals 2 cosine x. We know that the amplitude is 2, since that's the number in front of our function. What that also tells us is that this graph is going to go from a minimum of -2 to a maximum of +2, so that helps us know our range. Now, if we want to know the frequency, we look at the number in front of our angle. Since x doesn't have any number visible, we know that the frequency is just a value of 1. And the period is 2 pi divided by that value. So the period is 2 pi over frequency, which in this case is just 2 pi over 1, which will just give us a period of 2 pi. So that tells us how long it's going to take for our function y equals 2 cosine x to have one complete cycle. Now, the critical value interval, we spoke about this on the first day where we said the critical value interval is when you take your period and divide it by 4. This is going to help us label our x-axis. So this is going to become 2 pi over 4, which we can reduce to pi over 2. Now down here I left a spot that says critical values. What we're going to think about is if we're going to be plotting this domain from 0 to 2 pi, and we're going to be going over by a critical value interval of pi over 2, the critical values are what are actually going to go on our x-axis. So let's say I started at 0, and then I went over 1 pi over 2. Okay, but now let's say I wanted to go over another pi over 2. So think about adding pi over 2 plus pi over 2 would be 2 pi over 2. Okay, and then if I added another critical value interval of pi over 2, I would have 3 pi over 2. And then if I added another pi over 2, again, let me just show you what I mean. So we're continuing to add pi over 2. So when we added it to 0, it was just pi over 2. But then if we add it to a pi over 2, think about it like adding fractions. As long as the denominators are the same, you just add the top. So 2 pi over 2, then we add 2 pi over 2 plus another pi over 2 is where I got the 3 pi over 2. And then I would end up at 4 pi over 2 if I do that one more time. Now I'm going to stop at 4 pi over 2 because if you think about reducing that, my domain is going to 2 pi. So 4 pi over 2, if I reduce that, that is 2 pi. So what I'm going to do down here is just write them in reduced form. So I have critical values of 0, pi over 2, pi, that's what 2 pi over 2 would reduce to, 3 pi over 2, and 2 pi. So these are the values that are going to go along my x-axis. So now we're ready to graph our function. We just have to get ourselves on our graph paper with an x-axis and a y-axis so we know where to plot all of these points. So since we're only plotting positive x values, I'm going to put my y-axis all the way to the left of my grid. So we're going to let this be our y-axis. And since we are plotting range values in the negative and positive y value direction, I'm going to put my x-axis kind of in the middle. Okay. So now I'm going to label my range. So you could just go up by one box, but since we have a lot of room here, I'm going to skip 2 boxes and let that be 1. Skip another 2 boxes and let that be 2. Go down, -1, go down, -2. And now I'm going to plot or label my x-axis with my critical values. So again, we're only putting 1, 2, 3, 4 numbers from down here, if 0 is here, along my x-axis. So these 4 critical values, I'm going to skip a few boxes. I'm going to skip 4. So I'm going to go over 1, 2, 3, 4 boxes. Let that be pi over 2. Go over another 4 boxes. Let that be pi. Another 4 boxes. 3 pi over 2. And another 4 boxes. 2 pi. Okay, so we've really done all the hard work. Now I just want to remind ourselves, maybe up here, what a typical cosine curve looks like. So cosine will typically start at its maximum, go to the middle, then at its next critical point, it will go to its minimum, back to the middle, and end at its max. So the shape will be something like that. So when I go to graph this cosine curve, you know what, I'm going to stick with that color. The maximum for this cosine curve is up at 2. So when we start plotting cosine, the first point I'm going to plot is the point 0, 2. Now the next critical value, pi over 2, is where cosine is going to go to the middle. So we're going to plot that point. Now we know cosine is going to go to the minimum after the middle. So at pi, I'm going to plot the point pi negative 2. Then it's going to come back up to the middle at its next critical value of 3 pi over 2. So the middle here again is 0. And then at 2 pi, we're going to end back up at our maximum point. So now if we just connect these points with a smooth curve, not the smoothest of curves, let me try that again. We've now graphed y equals 2 cosine x. We're going to try at least one more. So now let's look at y equals sine 2x. So for this graph, we have an amplitude of 1. Since there's only the number 1 as the leading coefficient in front of our sine function, so we're going to know that that tells us our minimum is negative 1 and our maximum is positive 1. Here, the frequency is what's changing. So now we have a frequency of 2, which means the period will be 2 pi over 2, which really just gives us a period of pi. So now I know it'll take me pi units to see one complete sine curve. Critical value interval, again, is is period, which sometimes is 2 pi, but in this case it's not, but period divided by 4. So in this case, we have a period of pi, so if we divide that by 4, this is our critical value interval, meaning this is the amount of space between our tick marks along our x-axis. So if our function y equals sine 2x, that's our function. The domain is 0 to 2 pi. So if we're going over by pi over 4, our critical values are going to start at 0 and then go over by 1 pi over 4. So we're just adding pi over 4. So if I add another pi over 4, that would be 2 pi over 4. Then 3 pi over 4. Then 4 pi over 4, which really would be pi, but I have to go to 2 pi, so I'm going to keep going. 5 pi over 4. 6 pi over 4. 7 pi over 4. And I am going to stop at 8 pi over 4 since 8 divided by 4 is 2. If I now go to reduce these numbers, I would have 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 6 pi over 4 can reduce to 3 pi over 2, 7 pi over 4, and 2 pi. So since we're counting by a smaller interval, it's going to take more values for us to get from 0 to 2 pi. Now we have enough values, or we've figured out all our important information to start graphing our function. So again, since we're only plotting positive x values, I'm going to put my y-axis all the way to the left. And I'm going to put my x-axis in the middle. I'm going to skip 2 boxes again for my range. And I might not skip 4 So I'm going to skip 3 boxes from my domain. You know what? I'm not going to skip 3 boxes because I won't have enough room. So better move for me to have made here would have been to count how many boxes I had along my x-axis and then think about the fact that I had 1, 2, 3, 4, 5, 6, 7, 8 x values here that had to go across. I'm only going to be able to skip 2 boxes. So I'm going to go over pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. Okay, now for sine, let's do what we did before for cosine. So for sine, a complete sine curve will start at the middle. It will go to its maximum, back to the middle, minimum, back to the middle. So if this is my sine curve, let's try to recreate that on our grid. So I'm going to start plotting my sine curve at the middle at 0, 0. At my first critical value, I'm going to go up to 1, my maximum. Then I'm going to go back to the middle, down to the minimum, back to the middle. So notice that's a complete sine curve at pi, which does make sense since my period is pi, and that's how long it takes for one complete cycle. I need to keep plotting, however, because my domain goes to 2 pi. So I'm going to keep going. So now that I've completed one sine cycle, I'm at the middle. So at 5 pi over 4, I'm going to go back to the max, then back to the middle, 3 pi over 2, down to the minimum at 7 pi over 4, and then back to the middle at 2 pi. So when I go to sketch this, I should see 2 cycles of sine by the time I get to 2 pi, which is good since my frequency was 2, which is how many complete cycles you should see from 0 to 2 pi. Since we have one more graph in our lesson, let's look at this third and final example. Now we have a few things happening in this example. Not only do we have an amplitude other than 1 and a frequency other than 1, there's a negative in front of this amplitude, which is going to indicate that this graph is going to be reflected, but that's something we'll look at right before we start graphing. So let's first go through all the important information. So amplitude is a value that is referred to as height, so we always take a positive value, whether there's a negative in front of it or not. That's going to indicate the reflection, and like I said, we'll deal with that in a moment. The range is going to go from -3 to 3. Now our frequency is 1/2, which means we're only going to see half a cosine cycle by the time we get to 2 pi. And our period is 2 pi divided by that frequency. Now if we divide by 1/2, it's the same as multiplying by 2, which really means this just comes out to be 4 pi. So what that also tells us is we're not going to see a full cycle here. Since we're plotting over the domain 0 to 2 pi, I'm only going to see half of this cosine cycle because we're not going out to 4 pi, which is the period of this curve. Now my critical value interval is my period divided by 4. So 4 pi over 4 is just pi, which is kind of a nice value to count by because it's not a fraction. So if our domain is going from 0 to 2 pi, 0 is my first value, then 1 pi, then 2 pi. So that's it. Okay, so once again, I'm going to start by making my y-axis all the way to the left, my x-axis in the middle, or somewhat in the middle. Because I only have a few values to put along my x-axis, I'm going to skip by 4 again. Pi, 2 pi. And for my range, I can still skip by 2's. Okay, so we are ready to graph. Let's think about cosine again before we graph this. Now, typically cosine starts at its maximum. If we go back up here for a moment, right, it starts at its maximum, goes to the middle, the minimum, middle, back to the maximum. But if I reflect this curve, what's going to change is my starting point. So I'm now going to start at the minimum, go to the middle, then back to the max, to the max, back to the middle, and I'm going to end at my minimum. So when cosine is reflected, it looks something like that. So when we go to graph this, that negative in front, now I have to think about that because it's going to change where I start. So I'm going to start plotting my cosine curve at -3 for my range. So the point 0, -3 is my first plotted point. Now my next critical value is pi. So I'm going to go to the middle. And then my next critical value is 2 pi. So I'm going to go to my max. And because we have a frequency of 1/2 and a domain of 0 to 2 pi, we're only going to see that much of our curve. And that's it. What I would like you guys to now try are the remaining practice questions. The answer key is posted on Canvas, so you can look there to check. And try the first homework for the graphing, which would be homework 3. And I hope to see everybody tomorrow.